Hi and welcome back to a new episode of the R course. Here today we're going to talk about arrays. We already discussed in a previous video what is a matrix. Well, an array is an extension of matrices, but in multiple dimensions. As we already saw, matrices is a two dimensions structure. Here we have a previous statement or declaration of a matrix. We have the data elements, the rows and columns, and how to fill the matrix by rows or by columns. Well, as I said, an array is an extension of matrices. That means that we're not going to have two dimensions, row or columns. We're going to have multiple dimensions, and let's see the definition. This is an array. What's the difference between matrix and array? Well, the number of dimensions, of course. We can say that every matrix is an array. However, not all arrays are matrices. Okay, one single dimension array, well, is a vector. Two-dimensional array, a matrix, and so on. And so here we need to see that we're going to fill this array with numbers going from 1 to 24, and we're going to set our dimensions 3, 4, and 2. If you multiply 3 times 4 times 2, you will see that we will have 24 elements. Okay, then let's save this. We can see here that is the dimensions and the number of elements 3, 4, and 2. And we display it, as you can see. Why is two matrices? You can tell me. Okay, that's because the first two dimensions is a matrix. And how many matrices? 2. So we will have two matrices with 3 and 4 dimensions respectively. Okay, this is an array. As you can see, I didn't work with by row or something. Let's see how the array is filled. 1, 2, 3, 4, 5, 6, 7 to 12. That means it goes by column, as you can see. But the default is to fill the array by column. The same issue we had in matrices. Okay. Here, as I told you, a vector is a one-dimensional array. And we can ask if this is a vector. My vector is a vector? True. However, what is the difference here, or what I'm trying to tell you? That if a vector is an array, we can change dimensions too. Here we're going to say, okay, the dimension of the vector now is going to be 3 times 4 times 2. Okay, it's going to be a third-dimensional array. I'm going to change the dimensions. And now let's see our new vector. At the beginning it was a vector, now it's an array, of course. So when I ask the function, is vector true or false, it's false. It's not an array anymore because it's not a one-dimensional array. And there is a function we're going to ask is array. This function, we will use it in many cases when we are reading information. There could be a warning from R that we're working with an array and instead of a data frame. So we have to convert and basically in two sense. Maybe we have to change one data frame into array or an array to a data frame. Okay, and with this function we will know what we have. Okay, true is array. We converted one-dimensional array to a three-dimension array. Okay, vector. Let's see. This is a vector 1 with 3 elements, and the next element, vector 2, will have 6 elements. However, we can change, or we can use these vectors to a new array. the union of two vectors, in our case, we're going to unite them, as you can see. When you use the C, we bind them in a one-dimensional array, a new vector with 9 elements. And I'm going to define my new array in this way, 3 times 3, 2. 2, I mean, using this information. And it's going to be, as you saw in the previous example, the result. However, what's the difference between the previous example and this one? Okay, you can see here we had 24 elements, and 3 times 4 times 2, the result was 24 elements. However, here, vector 1 plus vector 2 are 9 elements. Okay, so if we have 3 times 2 times 3 is 18 elements. So how can we convert a 9 element array to a 18 element array? Well, R is going to fill every empty space with the previous elements. For example, here 5, 9, 3, 10, 11, 12 to 15 are the elements we already have in vector 1 and vector 2. However, the new matrix is going to be filled exactly the same way, following the last element. Okay, for example, 15, what is the next element? Is going to be 5, so it's to start again with 5, 9, 3, and so on. Okay, so it doesn't display any warning about, oh, you only have 9 elements for a 18 element array. Okay, this, if you can see here, I'm asking the structure of my array, and it's a numeric object, 3 elements, and 2 elements. Okay, the length 18, and as we saw in matrices, we can change columns names and row names, and matrix names too, in our case, because we already have 3 dimensions. Here, column names, row names, matrix name. Okay, of course, it's not going to be only 3 dimensions. I'm just giving you this example, but you can work with 5, 7 dimensional arrays. Here, this is the way to create a new array with some names. As you can see here, vector 1 and vector 2, 9 elements, the same dimensions. We already saw the results, of course. Okay. We have this result, but we're going to say, okay, columns, call 1, call 2, and call 3, call 1, call 2, and call 3, call 1, call 2, and call 3, row 1, row 2, and row 3, 1, 2, and 3, and the first matrix and the second matrix. Okay, here's something is, of course, here list, column names, matrix names, and the last one here. Okay, now let's see the result. Here it is. As you can see, we changed the dimensions names with using a list. Okay, call 1, call 2, and call 3, and row 1 and row 2 and row 3 are going to be the same names in every matrix we have. We have 2 matrices with a different name, but the columns and the rows have the same name. Okay, and how to access to every element? Okay, there as in the matrix, we're going to use commas for separating every dimension. For example, here's the third element from rows in the second matrix. Okay, what is that? The third element is going to be this and second matrix. That means there is this one here. But there are 3 columns. Of course, if I use, for example, okay, I want from the second column, it's going to be 12, as you can see. The same here. So we can leave one dimension empty, and we will have, well, the remaining parts, okay? And we can access to an element in the first column, first row, third column, first matrix, okay? And here, what is going to be, okay, if there is a missing the information for the row, missing information for the column, that means that we're going to print the second matrix. And that's it. The same here. Let's see another example. Vector 3, vector 4. No dimensions are mentioned. So what it's going to do? Let's see what it's going to do. When we don't mention any dimension, as we define here, like this, dim. So we're going to see that is a one-dimensional array. Okay, there are 10 elements. But if I say the dimensions number, we can change it to. And the thing here, we have 10 elements for 10 elements. However, 2 times 2 times 4 is 16. And as we saw, R automatically is going to fill the empty spaces. Okay, you can see we will have 4 matrices, 2 times 2 matrices. Okay, 1, 2, 3, and 4. As you can see, that some elements are repeat to fill the empty spaces. Here, 16, and it'll start again with 5, 9, 3, 10, 11, and 12. Well, as you can see, this is array, and this is how we work with arrays. We can ask if something or an object is an array, and we can see an array as an extension of matrices. Okay, this is all. This is arrays, and I hope you like it. See you next time.